Okay, everyone. Welcome to the Monday session or meetup. As you all know, we have been doing these meetups on Wednesday as a research paper reading. And we have started this Monday session, more of a sharing a little bit practical aspect of applications in GenAI space. Sometimes we go through some practical aspect like examples, show and tell. Other times we take a topic and then go through a little bit in detail. So by the way, this is a support vector meetup, and some of you who are joining new as a first time, welcome to the support vector meetup. We are in Fremont in Bay Area. Yeah, if you are nearby, you're always welcome to come to this training center. And as you might have seen the website, in case if you're not, it's supportvectors.io. You can go and look at and a lot of these courses and the trainings, all the things that we do is listed over there. Okay, let's talk about today's topic. So today's topic is about web crawlers and web scraping, right? In the era of GenAI. So some of you are familiar with the web scrapers and then web crawlers. So the idea behind today's session is to little bit give you the background and the historical aspect of the web crawlers, and then take you through the journey. How in this agentic era, you can call it as AI agentic era, how the web crawlers and web scrapers play a critical role. Okay, not only for builders like LLM builders, frontier LLM builders, and also for application developers at the enterprises and for startups, right? So we are going to go through the journey. Let's imagine you are going to develop an application, right? And I assume who are joined here, they have some idea about application development, preferably some GenAI based application. You guys are, let's imagine you're familiar with GenAI. You know what is LLM, you used LLM like OpenAI. And also you have developed or trying to develop some applications involving the data from internal websites of your company or from the websites that is available public, and then you wanted to develop some application. Okay, so what we are saying is let's talk about you're going to develop an application to retrieve some information from a website. And then you may apply some LLM language modeling to over the data, and then produce some valuable entity for your company needs or other needs. So in that context, right, you are assuming a lot of this knowledge is all over the web, and our goal is to extract the knowledge using the crawlers and then scrap it, and then identify the knowledge, and then apply your value, and then call LLM and then generate some meaningful output to the user. So that's what we are going to develop. That's your goal and target. And say, let's take an example of SupportVectors.io, right? If you go to the SupportVectors.io, that's for an example I'm going to take it today, and then go through this journey of crawlers and scrapers and then AA. Let's take in support, if you go to that site, you might see some of this is without login as a public user. If you go there, you would see a lot of the courses listed over there, right? And I'm sure you might have gone through those site a few times. So you would see all the courses, agents, and then RAG, summer courses, all courses, all the things are listed out there. And then apparently, let's say that SupportVector doesn't have any API. They don't support an API for that. So a lot of this information and knowledge is in the website of SupportVector, but there is no API. So what do you do? What would you do, right? One other way you can do, you can download the HTML page and then scrap it. Scrap it means extract that information from the page. And then you can think about developing some applications using that. Maybe a reminder for Sometimes you want to set a reminder. Sometimes you wanted to look at some detailed course information. So there are many things you can do. So this is just an example applications I'm just using for this class or for this session. So there is no API. When there is no API, the next thing you want to do is develop some scrapper, right? And a crawler and then scrapper. So essentially what you're going to do, right, when you're thinking about this, you're going to develop a crawler and the scrapper to extract the knowledge from the website. So that's just, sort of the context, to start with. The crawlers and scrappers provide us a lot of value, right? You can think about so many startups using these techniques and then adding a little bit more value and becoming a billion-dollar startups. You can see this over and over in the last, especially after what we call internet web era, starting from 2000, around the time. This is one of the major way to make a new value to the society. Bring in the data from web, scrap it, and then add your own value to the system, to that equation, and produce a new value to the society. Then obviously it becomes a billion-dollar startup. All right. So now, yes, it's possible to do that. Now let's imagine that the owner of the web page changed its layout, right? You saw that SupportVectors.io. We can go there just in case if you've not been there. Let me put that here. I'd say upcoming courses. So this is without the login, you can see all the course details, right? And there is no API that SupportVector provides. But you can still download this page and scrap the information, and then potentially you can develop some new applications over this. Okay, so what the session is about is, how do we, in the past, whenever there is a change in the web page, it used to be a tedious work for the folks who have developed prior to that, right? To again change the extraction, sort of logics, custom logic around that, and then get the value, right? Whenever the website changes, that's what typically happens, right? All these websites that we see, which has a lot of information, including Amazon and other type of websites, they do have wonderful knowledge. And as you start extracting it legally, first of all, we assume that it's sort of legal way to do that. And then you would see that, when they change the page layout or something, your code is going to break. So that's one of the big issue in the scrapping world, right? In the crawling as well as in the scrapping. Web pages, websites changes on a daily basis. Your code, needs to adapt to the changing times. So how do we see that particular domain, right, in the new era? Is there a better way to do that? Is one of the topic today. Before we do that, we need to understand a lot about a little bit history behind this. So what I'm going to walk through is I'm going to quickly review the web history, not more than 5 minutes. That'll some of the folks who are entering into this field in the last 10 years, they probably may not be aware of what happened in 2000 or 1995, how the web pages came into the world, and that gives a historical perspective for you, which definitely gives a added knowledge for us to handle some of the challenges in the new world as well. Then we briefly look at the components of the web page. We need to know a little bit, not too detailed, about what are the elements of the web page, where the knowledge is sitting over there. Before extraction, we need to know that. And then we do go over the some sample, I would say that, and also simple examples of crawlers. And then more importantly, we want to talk about the challenges, right? The way I'm seeing is, people who have developed the crawlers or even scrappers, they know that it's easier to develop for your own homework, right? For your own personal projects. But when you do it at a little bit scale level, what really going to happen is, many things can happen. One, as I said, web pages changes the layout. That's one issue, of course. The other thing could be, who were, hosting the website, bigger websites like Amazon, they watch out for the bots. They try to prevent you, from crawling and scrapping. It is called blockers. So other side who doesn't want these other applications, including the LLMs. Nowadays LLMs, what they do, right? All the LLMs, frontier LLMs, they go on web crawl, and then they basically index, including Google and other companies, right? Everyone does that. But sometimes these companies don't want other companies to crawl, or they want to crawl on a limited manner. Whatever that is an issue, they really want to prevent you. So they provide blockers, right? They enable blockers for the crawlers to come and get the data. And also they add so many complexities in the crawled data not to get great content. So what that means, we are going to talk about what we call static content and dynamic content. So those are very important concepts, all right? For us as a user, when you use the browser, you probably may not be aware, right? Which is a static, which is a dynamic. But when you peel the onion, right? Static content means something, when you go to that URL means the web page. The whole content is delivered to you. You pretty much see that in your browser, like a news or information. When I say dynamic content means, some of the HTML page comes to you, and then maybe you need to click something to view the more data. Maybe you need to answer some questions. Maybe there is a login button, right? And there are other things like AJAX calls. So there are many types of elements that supports dynamic content. So now think about, you are trying to extract, when you are purely in the world of static content, that is many years ago. People simply develop HTML, CSS, right? That is a static content. It's easy for the scrappers or web crawlers to understand the content and derive a knowledge out of that. But in the dynamic content world, it's very difficult. So then it's becoming a more of a professional level. Now we are from a little bit of a hacker level, simple coding, Python coding, or few lines of coding. Now we are going to go into sophisticated way of maybe unblocking or handling or automating some of those dynamic content extraction. Legally, again, I'm talking in a legal way. So that's a challenge still as an individual, as a small organization. There are many techniques involved in overcoming that. There are tools, there are libraries provide that capability. We guys need to learn about those, how to do that. And there are SaaS oriented. SaaS means people are hosting web scraping, web crawling as a service. They do take care of some of these complex situations. So for us, we need to learn more about how to handle the dynamic content, so that the knowledge we want to retrieve will be meaningful. Okay, just apply this to, I'm going to now and then talk about LLM also, right? Because when we talk about crawlers and scrappers, we are going to talk, both the way the current applications are handling or using it, and also the way, what is in new world, in the AI world, Gen AI world, right? In the Gen AI world, there are multiple angles to this scrappers and crawlers. One, you can say that frontier LLMs, how do they crawl? How do they scrap? And then open source LLMs like Llama and many such language model LLMs, how do they do, right? And the third part is how, as an enterprise application developer, we need to crawl our internal websites and maybe a little bit outside websites, and then extract information for our projects. And add to that, in the reasoning world, very important, we call web agents, right? Now, if you go to any LLMs, you see that starting from Perplexity, you see the dynamic nature of when you ask a question, it plans and then it takes steps. The steps could involve going to your website and then crawl the website, inside the web pages, and then extract the information. So these becoming the traditional web crawlers, web scrapers, in a way is becoming a critical component of the web agent, the deep research, the deep kind of agents. So those needs to do those crawling, and then scrapping dynamically on demand. So how do they do it? And if you can replicate that for our enterprise, is it not great that we can also create some reasoning engine which crawls and then extract and then dynamically decides and then recommend to you? So that's a whole idea behind this session. Yeah, that we end up with what we think as a web scraping. I will show some architectures, web scraping in agentic era, IA era. All right. So about me, I just want to introduce you about me now. So my name is Krishnan here. So I've been sort of part-time instructor in SupportVectors. I've been working in this field, what we call the, related to the web, since almost 1994 or 5. I remember I am one of the earliest web admin in 93. If you can visualize, there are very handful of websites. I'm going to show you some stats. You'll be thrilled to know, how we came from there to today now. So I've been handling. I was a web administrator, and I was playing with the web in the era of Yahoo.com before Google came. And our website was one of the top searchable website at the time. So you can imagine the way we handle a lot of this web traffic, and then learned a lot about how users are accessing the web when the browser was even in the infancy, right? So that gave me a lot of learning in the behind the scene, what's happening, browsers and DOM, and in the web server side, right? How these are interacting and debugging, all those things. So that gave me a lot of perspective about this, the whole web evolution, and then where we are today. Again, this may be interest to some of you. Quickly you see that, right? I mean, all these things that happened before the web era, and after the 83, where the TCP was the booming, right? There are many protocols developed. Followed that is a HTTP protocol, right? That is when in 1992, so one of the physics, during this time, 91 or 92, all the internet were basically mostly used by universities, exchanging the documents, FTPing, and then sometimes UNet, and then sometimes chatting. Everything was happening in a terminal-based approaches. And then these scientists in Geneva, right, they wanted to share their own internal documents, which included sometimes text and then maybe photos and then things like that, to one another, to the other research fellow in the other side of the world. So they saw this, the way of FTPing and then copying was very cumbersome, right? They thought about some interesting way. That's where the HTTP-based browser came in. All right, so that is really a novel idea. In other words, how to make it easy for the researchers to see the documents without downloading into one of their laptop or desktop or Unix machines, but at the same time allow them to see real-time updates efficiently, elegantly. So these things came. In the first browser came into the market, some of you know browser is Mosaic, right? It came in 93. I very well remember, I'm one of the first, as soon as it came, within a month or two, we started using it. And then followed that, this is a diagram you see in the right-hand side. This is how it looked at the time, right? I mean, you can still see the URL in the top. You can still see some of the buttons there. But this is pretty static, it handles the images and the text, nothing more than that. As you could imagine, the innovation here is a hierarchy way of organizing information, which links, right? So when this came, when the Mosaic was popular, at that time there was no Google, there was no Yahoo also, right? So as this web pages started getting more and more outside the university, and then more traction, this idea about building a catalog came. That's where the Yahoo.com came, and then followed by Google, right? This is sort of the historical aspect of that. And then Netscape was one of the very stable browser, was introduced as an IPO at the time to the whole market. it followed the Mosaic, but added a lot of features. And then, sooner they added the JavaScript, all the complex things we see today. And in '95, Microsoft launched the Internet Explorer, right? At the time, there was no Google Chrome. It came much later, probably around 2000 time. So these are all what we call browsers. The reason I'm saying here is from two angles. One, the browser technology, how the information is shared and how the links are embedded is evolving at the time. And number of web pages were exploding at the time. So now think about the knowledge explosion here, right? The way you can visualize the knowledge explosion, you can see in '95, the number of websites is only 25,000, 23,000, right? It boomed into 17 million in about 5 years. Can you imagine how many websites today we have? So these websites, yes, some of them are most of them are static at the time. But still, in terms of the number of websites, we then equal it to knowledge, is about 17 million websites. But and then by the time you can say 2003, there are many platforms came to develop these websites quickly, WordPress and stuff like that. So we used to hand develop these websites. We do use HTML. We hand develop the HTML coding, and then the website generators came. You see that 65 million websites around 2005, right? I mean, all I'm saying is the knowledge is exploding now. So at that point, there are not many APIs were not the norm. Static and dynamic websites are coming up. Some websites are giving APIs for data intensive applications. And then by the time 2024, you can now see that about 1.83 billion websites, right? And then that's mind-boggling to me. That means you have 1.3. It doesn't mean you have 1.83 billion IP address, but yeah, you can roughly say that. There are so many websites out there. All right. Why do we say that? That means the knowledge is sitting in so many websites, right? And then our goal here in this session, or we are trying to develop an application which harvests the knowledge in the websites. Sometimes which websites, that is great. That is the era so far we have been, right? If you want to target some websites, you may come up with 15, 20 websites for your domain. And then you do the web crawl, and then finally, scrap and then get the content. But now we are talking different LLM level, LLM reasoning level, LLM planning level, where these LLMs the reasoning engines need to decide the websites on time, and then go and crawl and then get the data all dynamically. So it's a problem is a multifold now, right? So that's a way I'm seeing in the new era, your concept of crawling and then scrapping has to be much, much more sophisticated. So I think we are in a new world in that sense. What is web scrapping history, right? I mean, along the way when websites are built and then all the catalogs like yahoo.com, then the Googles came, and then web scrapping started around the time, right? How do you build a Google-like company? Like you need to you need to first crawl the websites, understand the websites, sort of the category, and then you need to crawl the website, scrap the website, and then do the indexing. So you can visualize that, that's one of the starting, scrapping applications, along with a few others. Indexing the whole web pages across the world is one of the major application of crawling and scrapping needs, right? And this is out of the historical view. So after scrapping, and after the browser Mosaic and then Netscape was introduced, about 70 million sites are introduced, you started seeing the scrapping coming. There are Vantex of the world. These are all the libraries and approaches to scrap. And finally, there are some standardization or something came called BeautifulSoup. That is one of the most popular scrapping, I would say, engine or library. which handles a lot of complex part of the scrapping and give you the very high level, easy way to extract the knowledge from the websites. So this is a story of scrapping now. Okay, by this time, you guys know what is scrapping, right? And what is the difference between crawling and scrapping? Crawling is focuses on finding or discovering the web pages, versus scrapping actually getting the information or knowledge from those pages. That's a difference. By the way, how many of you, might have used these things? wget, think about this, right? Curl or Scrapy or Firewall. I'm sure one or other way you might have used some of those things. And a curl command is not a pure crawler, but it's more of a single page crawler. wget is one of the popular command line based, mostly Unix based. I'm sure there is a Windows equivalent to that, but it's a Unix based crawler. It's it's not a programmatic way, but it is like a command line tool based. So if you're not familiar, please get familiar. It's a very handy tool. And then Scrapy is a Python or a language-based approach to crawl the websites, right? And then Firecrawl is much advanced version of that. Here are some examples. So what we are talking now is crawling, right? We'll go to the scrapping pretty soon. And then we'll see the challenges of scrapping, right? And that's a goal. And then I'll take you to the agentic world, how we can visualize, crawlers and scrappers in agentic world. So right now, we are still trying to get through the curl command, very, very simple ones. As you see in the top one, if you do the curl HTTPS, what it does is it's basically downloading the home page, right? And then output that into your, as I said, it's a command line tool, right? It creates your local file system. You can try it out, curl HTTPS SupportVectors.io and see what happens. And then similarly, you can. This is very interesting. You can also change the ways that change the behavior of curl. See, when you access a web server, the web server, very interesting story. The people behind the web server who hosting the web server, they're not simply hosting it. They do a lot of insights, get the insights from the web server activities. What kind of insights, right? I mean, they can track you, track IP addresses, right? Where are the calls coming to the web server? They can block you if you're accessing, let's say, 500 times more, in a day or something like that, based on IP address. These are all sophisticated blocking mechanism to prevent your website either from not overuse or crashing, whatever the reason, they can prevent you based on where you're coming from. And then they also know which browsers you're using, right? Because based on the browsers, the web servers mainly websites need to decide. In some cases, it used to be the case in the past for Netscape, I need to do something different. For Internet Explorers, I need to return something different, tagging. It used to be that world before, not anymore. So you might need to handle those things, sometimes in the website. So for that, it understand the browser protocol. Browser communicates to the server when it's talking, when it's calling. That you can simulate in the curl command. So curl command act like a browser. Now we are getting into a little bit sophisticated. So I'm going to talk about what we call headless browser and the browser with the head, right? So it comes in the next few slides. But for now, imagine curl command is the simplest way to get one page. Similarly, wget is much more advanced version. Where curl command focuses on one page at a time. wget focuses on, you can say, the entire website you can download. But nowadays, if you try to use wget on a website, it might notice you. After a while, it will block you, depending upon how the web server is set up. But if it's a very simple web server website, you can still do this in a way. You can sort of extract. Before extracting, you can download the HTMLs from these websites. So these are some of the examples. As you could notice here, right? The recursive means, you guys know website means it contains multiple sites, right? Sub pages, sub URLs. So you're telling the duplicate command, recursively find out all the pages and then copy into the local directory. Okay. And then, you can further expand into Scrapy. Scrapy is a Python-based programming where you have more control. You can copy the files in a specific directory. And this is a starting place where you think about Scrapy. Now you have more control as you're downloading the HTML pages. Now you have control to inspect the HTML page, right? And then you can extract knowledge. So our eventual goal later, right, when we think about agents goal, reasoning engine, is to process the HTML and then figure out some data. Okay, this is a quick comparison, right? Just to summarize, we can just look at one or two aspects of here. Duplicate is a CLI tool, curl is a CLI tool, Scrapy is a Python framework. That's something you want to know. Well, the duplicate and curl doesn't support, of course, JavaScript. So now we are entering into the world. Imagine I was so far talking about, pretend I was talking about HTML, static HTML. Static HTML contains only a few things. HTML, CSS, and then probably images, right? Photos or images. But dynamic content means, as I was saying, JavaScript, and then JavaScript gets activated based on some events. All those things were part of the dynamic content. So duplicate curl cannot handle that. Obviously, you need much more sophisticated tools, including Scrapy for that. And then recursion, yes, you probably noticed that. So these are the few things you want to aware of that. Okay, so we are talking about comparison between command line tools and Scrapy, but you can there are tons and tons of information in the internet or your popular LLM. Go and ask. So these are all topic is what are the popular web crawlers. So it's going to spit out some of those things. Personally, I used Scrapy a little bit. All other things. Stormcrawler is popular in enterprise. Yeah, you can see that. Eventually, it comes to two aspects, right? One, how do they handle dynamic content? What is the scalability? How do they handle timeouts and stuff like that? All those things, and large-scale web crawlers, right? How do they handle multiple websites? You have a need to crawl multiple websites parallelly. So all those things go up in the complexity. So based on that, there are various tools and frameworks. And then, as I said, the services came, software as a service, right? There are many web crawler services available to you. You can set up an account and specify your conditions and then configurations. It will download even to your S3 bucket in Amazon. All kinds of things are there. Okay. And this is more of telling you, these are basic libraries. So you need to be aware before diving deeper, but I'll cover that later sometime. Okay, so now we are going to a little bit, probably a little bit duplicate, but quickly, right? Static content refers to all elements on the web page. Yes, correct. That is directly into the HTML document. Dynamic content means it's not fully rendered at the same time. It will be rendered as part of the execution, JavaScript or Ajax and stuff like that. Or WebSocket can push the data. The server can push the data as well. Okay, now let's ask the question. Based on your knowledge, let's go to SupportVectors.com, right? So is it a static content or is it a dynamic content? What do you guys think? Think about it, right? I don't know, I'm not feel down in it, but how do you figure out whether it's a static or dynamic? Any thoughts? Anyone want to say that? Terry, for example, you are here.
One way is to inspect the web page.
Yeah, correct. Look at this. Is it a static content or dynamic content? Right. So right now it appears to be static content. It's very difficult to say from here, right? You need to do the view source. You need to do, if it's a Chrome, you need to do the developers and then look at whether it uses any AJAX call, or all the content that you see is embedded in the same HTML, but it gets displayed here. So we cannot visually conclude that it is a static or dynamic. All we can conclude, every website has both elements, right? Both static and then dynamic. So the idea is no website, unless it's completely written many years ago, it's very unlikely that it is static nowadays. So one of the way is you look at the view source and then figure out and look for AJAX call, right? Look for JavaScript, look for something like that. Then it's a dynamic website. Okay, now again a little bit very high level. I'm not going to go into detail. So what a web page means, right? Web page components. What are the web page components? It has a HTML context, HTML tags, and then it has CSS, that's a cascading style sheets, and then JavaScript, and then assets. Is it anything more than that, guys? Anybody knows? This is a pretty broad classification of a HTML content. So somewhere, now we are applying the hat, think about AI agents and LLMs. They'll be essentially, the knowledge is sitting inside these things, right? So LLM open source, closed source LLMs somehow get the data, and then they are able to train their LLM models. And then open source LLMs also do that. Now, as an AI agent, one of the I would say popular agentic application that you may guys know, many, even Perplexity, is an agents-based application. And the code, there are code assistants. Those are all agents-based applications. So most of these are deep research and all kind of research platforms that all the LLMs provide. These are all agentic applications. So all these agentic application, they need to derive the knowledge dynamically, right? Efficiently. Okay, so now that takes you to the little bit of technical words. What is a DOM? So these three elements are important. Why is it important? Now, with that knowledge, you can develop a serious web scraping. The web scraping is involved so far in manipulating the DOM. DOM is nothing but when your HTML content is retrieved or downloaded, you can say, by your web crawlers. Now you have HTML page. In the HTML page, so many things are there. How do you go and take a piece of that? That's basically called DOM. DOM, document, object. M means model, right? So the way to get the knowledge from the DOM, there are probably a few ways, but popular way is CSS filtering query, and then XPath. XPath is like a recursive way to go to a node, DOM node. So I won't be going too much into the detail, but at the all guys we need to know is there is a DOM there in the HTML world, and in order to extract the knowledge, you need to be a little bit familiar with the DOM. So that's what you need to be taking it now. Now, if you think about all the CAPTCHAs we developed, right? Every DOM may need a special, or every HTML, you can say, need a special way of handling, extracting, and then making sense of the knowledge. We really don't know how Amazon is creating the DOM, where they embed all the product's knowledge, right? Product ID, product description, product price. Similarly, we don't know how SupportVector is organizing the DOM. So that's what the website side, in this case, Asif will be building it. Suppose you want to extract from here, you need to know the DOM, right? And then if you know the DOM of this, if you know the structure of the HTML page, you can find out what are the courses listed by the SupportVector site without API. Now I can list it. I'm going to show the code, which is going to list you, which is going to actually process the DOM and list the courses from this website. I'll do that. Well, okay. So what I'm trying to say here is, in order to write the efficient, scrappers to extract the knowledge, you do need to understand the DOM. But the way we are going to do it now in the agentic world is different from the way we have been doing so far. So that is what we are going to end this session. Now, if you go to the last slide, what I'm going to show, this is how you have been doing it so far, and this is how we are going to do it in this world. So I'll come to that as the slides go. But a little bit understanding is always good. So XPath syntax is like that. XPath is a hierarchical based approach to reach a DOM element. Again, this we are going into a little bit more detail, but I mean, these slides might help you later on. But this is just for a reference. Imagine that this is how you can manipulate the DOM. Okay.
Sorry, can you repeat what you just said earlier? You said it's a hierarchical approach to, I think, was it?
So yeah, so DOM is though I didn't put the diagram here. DOM is organized in a hierarchical way. In the same way, any website, you may know that, right? They have some content, they have some URL, the HTTP link, and then when you click on the link, that page may have another link. That's a hierarchy, right? That's a hierarchical way the information knowledge is organized. In the similar manner, in the DOM, all these things you visually see, you may see it in the boxes here, but it is organized in a completely different way. When you go to the source, internally it is organized in a what we call hierarchical way. What does it mean? Have you? I mean, I don't know whether you used a browser's extension called Developer. That is to see inside what's going on. Let me see whether in this machine they have. I mean, I do have in my machine I have, but this may not have it. Let me show you from the. I'm going to show you. Hold on 2 or 3 slides. I'm going to log into another computer. Then I'm going to show you that. What is DOM? What is a hierarchical? Just hold on to that if you don't mind. Okay. So what we are saying is that DOM is a hierarchical way to organize the HTML content, which gets displayed in the browser to you, right? So when you essentially we are saying when you crawl a data, when you crawl a web page, when you download the web page content, then when you are scraping it, we are going to use the DOM libraries to scrap. When I say DOM library, it's a Python library. Sometimes here I use the word HTML parser, but it's kind of the same. HTML parsers are nothing but a DOM parser, DOM content parser, right? And then I can use something called CSS filtering and then export. This approach to go inside the DOM. DOM is imagine that's a model. I can navigate the DOM using these filters and then get the knowledge. If your goal is to write a sophisticated web scraping, you need to understand, right? And this gives a foundation, and you can expound on that. And by the way, of course, without saying in SupportVectors our training, we all go through this. A lot of our our agentic AI courses and LLM bootcamp have so many practical projects involving these examples or manipulating the DOMs, which eventually get you the good knowledge. Okay, so now we are going to, I do have demo, I'll come to that. But before that, just want to say that now that you are able to visualize crawlers and then visualize some aspect of the scrapping, we also need to keep in mind, right? Well, can I, there are other elements which is trying to block you, because some websites don't care. You can take as much information from their website. Some websites do care. They try to block you. So only in 2 or 3 things. One, what they call TLS fingerprinting. Other one is the IP. So they watch your IP, where you're coming from, and then they rate limit, or they can block you, right? Don't come back again. Or they'll say every day only 3 times or 5 times. Another, they block you. That's called bot blockers. And then some of them, they identify you based on your behaviors. If you're writing imagine, a lot of the SaaS services, what they do is, interestingly, yes, you can prevent IP, but some of them, what they do is they provide IP proxies. That means if you subscribe to some, let's say SaaS service, which gives you the web crawler, they of course charge you, and then they will say, I rotate between IP addresses, right? So that the web servers which prevent the call from the same IP address will not get noticed. So sometimes the corporation needs that, right? I mean, for various reasons, the other web server prevent too many frequent calls, but you can switch the IP address and then they get bypassed. Similarly, the web servers look at your behavior. If you're calling some URLs without any pause, right? Like immediate clicks, they know it's not a human. They can find out. And then they look at your other browser-related, information, user agent, locations, and then they can prevent you. And then they look at some of the security aspect. So there are many ways the web server can decide to prevent you or not. So equivalently, there are many ways the workaround folks create to avoid that prevention. I mean, again, for various reasons legally. So good to know, right? What is going to be your blocker? Again, if you're just a small developer trying sample application, nobody cares. But if you're developing an enterprise application, especially true in the agentic world, the reason I'm saying these are important, we are now into a completely different world. We are going to write agents, which is going to go to going to the websites much more frequently. And then, so this is going to be an interesting problem. When you are writing the agentic based, the reasoning based, it goes to multiple websites and get it. So I don't know anybody is talking about this problem. It's a very serious problem. So you need to be understanding how to at least know it or manage it. Okay, HTML parsers, right? Well, okay, now the question you asked, I'm going to quickly go into the example. DOM and HTML parsing. HTML parsing is a way to manipulate the DOM. And there are popular tools. BeautifulSoup is a Python-based library where you can, after you download the HTML page through web crawler, or you can even do for your learning, just simply download using save as in the HTML browser. You can create a HTML parsing tools using BeautifulSoup. Remember, I was telling BeautifulSoup was created in 2004. That is one of the most popular application to scrap the web content. Okay, examples, right? Examples. I need to log into another computer. Let me pause here. I'm going to pause only for a moment. I'm going to unshare. But stop share. I hope I can do the share here. Okay, I'm going to be talking from different computer for a few minutes and then move back. And so I'm going to share my Visual Studio. One second, I'm still sitting up. All right, yeah, I hope you can see my. Do you guys see my window? It's a cursor, right?
Good to
so
go.
what I'm trying to, yeah, correct. What I'm trying to illustrate is simple example for the folks who are new to this. Let me example. So what I'm trying to, okay, and one more time. So I'm going to, I set up this page. So as you see, what my goal is to list all the courses that SupportVector offers. Right? So we are looking at the page, web page, and we saw. But here, let's say I have web scraper, right? I am, using the BeautifulSoup. I'm using the Panda just to list the, I don't need to use, but I just use Panda to put it in the data frame and then display. All I'm doing is a URL. This is a URL. So of course you can embed your favorite application you're trying to extract information, and then you're calling request.get URL. Request is a HTTP library. So at this point, this is a simplest web crawler, right? And I'm not this purpose of this small program is to show you the web scraping and extract the knowledge, not the web crawling. So I used the very simplest crawler, one-page crawler. So it went and got the HTML in the response object, right? And then I'm using the BeautifulSoup, basically saying, hey, whatever you downloaded, the page, consider as HTML, use the HTML parser. This is nothing but the DOM parser. Imagine it's a DOM parser. Then you got the DOM. So soup is the DOM structure in the memory, Python memory. Then all I'm doing is, I'm saying from the DOM, select this, this is how the DOM is structured. Called, go and filter on the course box and course name. Okay, I'll show you what it is. The way to inspect the DOM, if you are familiar with Chrome, I'm going to show the Chrome. Okay, let me put it here. So I'm going to, so I'm going to put the same URL here, right? So this is how you're getting the page now, right? All these things. The way to know the DOM, someone asked, go to developers, right? View developer, and then you can say inspect elements or developer tools, right? If you do that, what it is doing, this is a DOM. This is a left-hand side, it's showing the, whatever it's presenting, but here it's a right-hand side, it's showing. So a lot of interesting thing happen. People who are familiar with the DOM, they can, they can move the cursor and they to show the HTML code. So one of the things I noticed, I see, AI assistants coming up. That is interesting. I never noticed it before. Like any other tool, your AI assistance is going to be helping us much more in the future, but right now very limited one. You can search and you can, I don't think you can replace and stuff like that. But anyway, the point is, if you control F here, you can say course name, right? And then these are the DOM elements. You see all the courses names will be coming here, right? So this is how you're going to search inside the DOM. I mean, this will take, don't worry if you don't understand this. Right now, it looks all Greek and Latin, but imagine this is a DOM structure. In the program, what you're doing is, you're basically filtering. You're going into the DOM structure and say, give me all the courses. That's how the courses are listed in the HTML. And then you put it in the course list and then print it. So this is how, let me run it now. If I run it now, so as you could see, this is like a little Python, not clearly outputted, but you can see that the data frame shows all the course title, Python with calculus, all the course, and the corresponding URLs. So where is it coming from? This is coming from these DOM entries. These DOM entries are visually, looking to you like this. So there are three aspects in this example. What is visually you see? It looks very eye-catchy. It's not great. But inside this, there is a DOM, which is a hierarchical based structure. And this is how, when you go to the website, Wix and other popular website generator, you might have done it. They all, visually you create the blocks, it generates this HTML blocks.
Not for me.
Yeah. Sorry. Maybe some, yeah. Okay.
We're getting feedback, but I did have a question. I'm hoping you can answer.
Yeah, it was not clear.
I'm really interested in XPath. I'm familiar with all the other things that you've mentioned so far. I know this might be new to others as well for particular parts, but XPath is something I'm not the most familiar with. So where do you find like XPath if you go to the SupportVectors website, is it in there somewhere? Like,
yeah, it is something. You see that there's an example here, export.py. So it's another way to represent the node of the BOM. So one is filtering without giving references, which is called CSS-based ID filtering. Other one is you're giving the whole path like this. Here we run it. If you run it, this example, that's why I have two examples, XPath and then non-XPath. So it is also it's able to figure out the same information, but slightly differently. So this is how, you start from the root, go to the division, and then find out the class, and then do these things. So I will check in these examples, but again, today's goal is to just give you an idea, right? Inspire you. So give you an overall theme behind that. So yeah, as he said, some of the folks joined, they may not be fully familiar with the more detailed one. Sorry. Okay. Okay. Thank you. So, I mean, I'm going to stop here because we need to move on. But this is to give you an introduction to this, right? Obviously, you know, there are so many courses about the DOM which can go much more detail into that. Well, let me stop here, and then I'll come back to here. Okay, you guys see now examples, right? So what we did is I'm sharing the screen. If you don't see it, let me know. So we just shared an example of simple DOM manipulation, just to enough for us to continue our presentation in terms of extracting the information. All right, what is dynamic content? You know, this is the most important one. So for static is great, but when it comes to dynamic content, you know, so many issues, right? It can contain JavaScript, it can contain WebSocket based data coming in, or Ajax based API call being going on. So how do you deal with these things? So then it becomes complicated. You know, not only you know, in today's world, in the new agentic world also. You know, if there are websites, you know, it is based on Ajax call. How does that LLM reasoning engines, right, or the planners, or one we are going to write ourselves, how it's going to handle those things? That's an interesting question to ask ourselves. That means we need to be learning more about how to extract dynamic content, right? So it's all based on JavaScript. In most cases, now dynamic content, the root, the basic behind the dynamic content extraction is JavaScript. All right. I mean, I asked the question, right, to Terry here, and then yes, you know, there is no simple way to say we need to inspect the pages. Also, you can look at, there is interesting, you know, how many of you know there is a network section in your browser's DevTools? I need to switch back, but you know, imagine you're the same tool that I showed, Chrome. There is a page called Network, where it will show you all the aspect of communication between your browsers and then web server. So if you're going to supportvectors.com, it will show you, you know, it's not single page. There are multiple pages. It will recursively call supportvectors.io dynamically. And then, you know, that shows that there is a lot of dynamic content will be there. Still, it's not easy. It is not a foolproof system. Sometimes the event or action that you do in the browser will invoke the dynamic content. So it's a combination of the network session in your browser and then in the behavior it is expecting from you. All these things will tell you whether there is a dynamic content or not. Well, how do we deal with that? Well, that is the biggest market there, right? There are many products came. These are all before agentic era or agents era to deal with the dynamic content. You know, essentially we are talking about how to emulate the browser. See, the browser deals with the dynamic content, right? The browser like Mosaic or the Chrome, they all understand how to deal with the dynamic content. But you know, the Python program that I showed you, BeautifulSoup, doesn't deal with the dynamic content. However, you know, tools like King, you know, Playwright, Selenium. Selenium we probably used, many of us used for UI rendering, UI testing. Behind that, it's all the same technology. You know, how do we deal with the dynamic content, right? And it comes into two, you know, it comes down into two concepts. What is the concept? Let me quickly show you one sec. Yeah, the concept is called, you know, two things. What we are trying to do in order to handle the dynamic content, we need to replicate the browser behavior in your system. It's laptop or server, wherever you want to extract the dynamic content, we need to replicate the behavior of browser. And it is called headless. You know, there are two aspects. Sometimes it's called headful and headless. Headless means it's something, it looks like a Python program, but it emulates a browser. It can emulate the dynamicity. Headful is same, but you can, you know, basically shows what's going on as it is. It's like Selenium. Selenium, you can see that it's a headful type of a dynamic content manipulator or dynamic content extractor. So that's a concept you need to be familiar. Then there are you can research on what are the helpful platforms available, frameworks available, services available. You can find out. Similarly, headless. So what our interest here is most likely headless, right? When we are thinking about writing an agentic application, right, or a reasoning application, we might be thinking about headless application for our dynamic content retrieval. All right. So with that, that's a two concept you need to be familiar. Let me go back. Oh, okay, 1 second. Sorry, I went down. 1 second. Sorry. The mouse is not going there. All right. Tools for scraping dynamic content. Okay. JavaScript heavy, right? So, I mean, root of all the things are JavaScript. When we say dynamic content and we need a scrapper, we are talking about, we are saying that website is JavaScript heavy. I mean, because every aspect of the dynamic content is JavaScript. And then there are a few things you need to be aware. There are in the world a single page application, React applications, and then there are so many after the HTML, the static based application development, when JavaScript came, and then later what we call single page applications came. In other words, that's another UI technology came where you download the applications as a single page download. Right? I mean, this is more of a technology who are familiar with web, creation, application, using a lot of, not the regular web page content, but there are many products which uses the web technology for their products. It could be an on-prem products, security products. So a lot of these things, you can see the single page application. The SPA, it's called SPA. So the SPAs are heavily based on JavaScript, and it's heavily based on dynamic content. The way it gets the information to you, either based on your username or based on what you provided. And the single page application now talks to the web server backend using the APIs and get the data. So how do we deal with those situations? Can we deal with this situation in the world where we want to extract information? Or it's not possible, right? Unless the web server provides API, that is the real way to do that. If the web server or application host, they provide the API, we can use the API for our integration. However, if they still provide the content that is appearing in the web page as a SPA application, what do we do with that? They don't provide APIs. So these are the things you need to keep in mind when you're thinking about the agentic application rendering the HTML pages. The user-driven interaction. Okay, so which I told you, sometimes login, sometimes you use some information, then it gives you the information from the web server. These are very difficult problems to solve. Maybe this is not solvable for the folks that LLM builders. Now they are building a lot of these open source LLMs or closed source LLMs. This may be difficult for them or not needed for them. But if you're building an enterprise application or you're building in a startup where you are trying to aggregate the data from different providers or different applications, these things are very important. We saw headless and headful browsers. Challenges in the dynamic content, right? Well, there are many challenges, right? One of the challenge, have you seen that CAPTCHA, right? That's very interesting. That's one of the way every website is trying to block you for security reasons. But when such things come, apparently, I don't know whether SupportVector has that. Apparently, probably not. But you see that, right? If you have web server or web pages, that requires you to, select and then confirm what they call CAPTCHA. So what do we do with that? Right? Well, those are the questions. These are the questions. Maybe these are difficult for new developers, to to overcome that. But there are sophisticated services and tools allows you to deal with these things. So if you are into serious programming aspect of this, yeah, you're welcome to read more on this. It's called anti-scrapping and anti-bot measures. You can Google it on it. That will tell you the techniques and then SaaS services available to overcome that. Essentially, it is come down to DOM manipulation. The folks who have developed this, they are able to manipulate the DOM, and they are able to simulate the behavior like the way you behave when the web page has a dynamicity, and then still able to get you the answer back. Okay. All right. So just to conclude that, it is not a simple problem. It is a complex problem. One need to spend good amount of time to play with that, understand, to deal with the dynamic, how to extract the dynamic content. All right. So Playwright is one of the popular ones. Selenium is another one. Puppeteer is another one. So these are all popular tools available in the market. I'm going to ignore the Ajax call. Ajax is a way in which you can, a lot of this single page application or regular application will going to be calling the APIs that server provides in a continuous way or in an event-based way to get the data back to the browser, and then it's rendered in the DOM element. So for now, I'm going to ignore that. We'll go to the next one. Okay, we are going to conclude this, right? So before we go into the agents world, the new world, we are simply setting the context, saying that you can go through this as I'm talking. There are static content, there are dynamic content, and it's very important for us to know the limitation of our tools in dealing with the dynamic content, because it's becoming more sophisticated. And in addition to the static and dynamic content, there is an aspect of blockers, right? They watch your IP address, they watch your behaviors, they means the web server, behind the web server you are trying to deal. So those blockers will also prevent you in getting either static or dynamic content. So it's a world out there. It's very complex, and in a good way that there are a lot of problems to be solved in this domain. The way I think is it's an opportunity for a lot of us to understand this more deeper, and then how this can be applied to agents world. So now we are going to switch to the agents world. So these are the problems exist even before the agents, right? These are the problems have been there for the last 10, 15, 20 years. But now it's the problems are much more and the needs are much more. So let's look at some of the architectures, I'm switching into, what I'm going to show you. There are 3 or 4 architectures I visualize. Just illustrates the components of this, crawlers and then scrapers, and then how we can see that in the agentic world, right? This is the simplest architecture diagram. You can say your application is here, right? Your application, like the way we developed survey, support vector list courses, right? That's our application, imagine. Then we used, in our example, we used the request library, but imagine you used the Scrapy library, and then the Scrapy library downloaded the HTML, right? And then it told the BeautifulSoup to extract it, and then the BeautifulSoup update the knowledge, etc. knowledge into the repository. So this is the simplest architecture. I'm going to walk through 5 architecture. These are very basic. This can be done. It doesn't have scalability. It's kind of a POC MVP type of application. You can use these tools, Scrapy and then BeautifulSoup, to download the static content, right? Scrapy does handle a little bit dynamicity, but it's not foolproof. Okay, this is the simplest architecture. What is the next architecture? Next architecture is same, but now we are talking about a lot of scalability. Okay, I think one arrow is missing. But imagine that you have so many custom handlers to handle. You are dealing with not one website. Like in the example, I dealt with only SupportVectors.io. Now you need to manipulate different types of DOMs. So you need a custom handlers. So now your code is becoming more interesting, right? If you want to support multiple websites extraction for your domain, you're extracting some product information from Amazon, and you're extracting from Target, and you're comparing both products, and then your agency is going to recommend something. Imagine those kind of applications. So now your extraction has a custom handlers. So this code base is going to becoming more and more very complex, right? Handling different DOMs to extract the information. At the same time, you also want a distributed architecture. Yes, you develop the POC, MVP to prove something, but now you're trying to make it as a service. You got a wonderful idea, which could be a $1 billion idea, unicorn idea, right? You cannot take the architecture one. Now you need to scale it, right? How do you visualize the scalable architecture for web crawlers and web scrapers? So that's very important aspect of the design. And by the way, these are all not new problems. You can search the Google Perplexity. You can say, how do we design distributed web crawlers? It might tell you some hints and all, right? But if you're really serious about that, you may need to study about distributed architecture, like Kubernetes, array architectures, things like that. You want to know how to put together these components in a distributed way. All right, and then next one is about, as you are saying, right? Yes, in the new in this, well, somebody created a service, SaaS service, Firecrawl. There are maybe more than 10-15 services that comes to my mind. So they developed the whole distributed architecture for web crawlers, and then for extracting knowledge, right? And then obviously you pay a fee for them. They expose their sort of working thing for you as an API. As an application, you register to that SaaS service. These are the websites I want to crawl and extract, right? And then these services provide a real value addition. If you look at the top, they take care. They are basically behaving as a proxy to you, right? I mean, instead of you running in your laptop or server, as you specify, they are running in their data center. So the web crawler, their way of knowledge, though it's invisible to us, but they are able to manage the IP rotation, blocking, and CAPTCHA avoidance, and then things like that. They are very sophisticated. So this is where they outshine. They shine, right? We may not be able to do that level, level all of this unblocking they do, and then rotate the users. Imagine, right? I mean, a lot of websites, as you may know, it may behave differently based on location. If you're in US, even within cities, they behave differently. And then think about outside countries. So now you want to develop a wonderful idea. Your data collection has to be very, very similar to the way user actually be in the other country, and then see the products and the numbers and all. So how do you do that? So without such services, you really cannot do that. So these are third-party services available for you, right? And then these are some of the examples that scrappers, Firecrawl, Gina, Spider Cloud, Agent QL. There'll be maybe more. I think Firecrawl is very popular. I'm sure others have some differentiation as well. All right, now we are entering into the new world, right? In the new world, now we have LLM, right? Large language model. How do you visualize in the new world? Okay, we're still not the agents application. Imagine you have some application, right? You have an application which lists the courses from SupportVector, or compares the price with other things, things like that. So many applications, as you are saying, right? There are thousands of startups, thriving just bridging the gap between one site and other site, and then adding value. Thousands and thousands of website, products, I would say that. So now in the new world, what we can do, web crawler, we can still use the same crawlers that we use, Request or Scrapy or Firecrawl, which extracts the knowledge, HTML page. And then instead of BeautifulSoup, can we think about using LLMs to infer the knowledge? That's out there. Extract the knowledge from the HTML page. There are pros and cons, of course. I will tell you about pros and cons, but there are benefits as well as issues as well. Can we use LLM like Llama or DeepSeek to give a page and then ask the page LLM and tell me what are the key aspects of that knowledge that I'm looking for? You could do that. It can be easily done. So what's the benefit? You don't need to write the complex custom, the handlers. Instead, you may write a prompt, but you're not going to write a custom handlers to manage that. So with the prompt, and then with the LLM, would you be able to prompt engineering? Would you be able to extract the knowledge? Quite possible. And it is good, right? Because your cycle of development is much less, right? Imagine I was saying that other website changes its layout all the time. Then you need to have programmers and the developers deal with that. Here it will be much more easier. Still, it's still there is a cost here, but adapting to the new layout, developing the new layout with the LLM-based knowledge extraction is much cheaper in one aspect. On the other aspect, it is also not. Can you guess what it is? Terry is here, so I'm going to pick on Terry. All right. So it is an expensive one, right? I mean, if things are not changing and the LLM calls are expensive, and it depends upon how many calls you make. So there's a cost involved in that LLM way of extracting the knowledge. If you happen to have local LLM, which is cost effective, it's good. But you want to watch out the cost and then see traditional, CPU-based custom handlers are better, or LLM-based extraction is better. Something you need to compare and decide. Oh, the final architecture. Okay, I think this architecture, it's not final. There is one more. So in this architecture, what you're seeing is now the agents are, we are talking agents now, right? Agents, agents. Can you think the web crawlers as an agents? What is agents? I mentioned instead of web crawlers, I put AA agents. Similarly, for knowledge, I put the AA agents, right? So AA agents are, if you have, gone through some agents course, agents, understand the environment, right? Understand the stimulus coming to the environment. I'm talking in general, and then act upon it, and then respond back, and then monitor the environment, right? So it has multiple roles to play. In stuff, of course, it uses LLM for its reasoning. So agents consist of autonomous reasoning, and of course using LLM, right? We don't need to worry about which LLM. So it has a reasoning engine using LLM. It's able to communicate to other agents for that reasoning to complete the goal, and it's able to understand the environment better and coordinate with other agents automatically. So there are a lot of autonomous decision, autonomous communication, collaboration happening within agents. So can we write web crawlers to make that agentic-based crawlers, which is much more sophisticated? Well, it makes a lot of sense to the extract knowledge is coming, but again, even in the crawler world, handling the IP rotation, right, simulating the users, and unblocking some access, can the agents play a different role? So that's a question. So as of today, I have not, though these secrets are within the big guys, Perplexity, OpenAI, Llama. So who are open source, deep research? All those guys, have instrumented these two things, crawling the web and then extracting the web using the agentic approach. So our goal is to see and then simulate us for enterprise needs. So can we visualize the crawlers as agents? Can we visualize, extracting the knowledge, which is scrapping as an agents? And then as part of that, have MCP-based tools approach, tools providing you the key capability using the natural language in which the other agents can, leverage that. So with all this idea, this is where I think most of the enterprises will be thinking about, how to build the next generation, more than chatbot, reasoning applications. Well, and that is within the enterprise. But if you are thinking about a startup, right, trying to get so many other, crawl other websites, get some information, then you need to worry about IP rotations and then how to simulate the user as the way browser simulates. Things like that you need to be worrying about. I think this architecture 6, it's a final architecture. So it's just an extension of that, right? What I added in this architecture, you see two things. I just added a multi-site reasoning engine, what we call web agents. That's a terminology I started seeing. So it's just expanding, right? You are instructing, this is a step towards, deep research type of feature, which decides the planning, and then it decides these are the sites I need to go and analyze, and then it offload that request to this multi-site reasoning engine component. Let's call web agents, and then which then goes into the AI agents, get the data, which is HTML, and then use the knowledge, AI agents to extract the knowledge. So this is architecture. Of course, as he said, enterprises are trying to build for their applications now. And as you see, as part of that, you build custom tools, right? As part of this multi-site reasoning engine, not only you have access to the tools that the framework provides, you may also need to have access to the custom MCP tools. All right, that's the last slide. Let me see. I'm going to skip this now. So in the interest of time, and these are the takeaways, right? The goal of the today's session is to introduce you the components of crawler and then scraper, right? It's a little bit of historical aspect of that. And where we came from 27 websites in 1994 to 2 billion sites now. That means so much knowledge is all over the web, including Wikipedia, right? We all know how much knowledge it has. And then the pitch here is, hey, in the new world, open source LLMs or closed source LLMs, they're all implementing this web search, talking to the sites and then extracting the knowledge. And then for others like us who are building enterprise applications, startups, we may want to know how to do that for our own needs, right? How do we scrap and then crawl as an agent based on agentic approach? And then how do we use MCP tools, in this new world? And as part of that, we understand the issues behind that, blocking, IP blocking, dynamic content. We understand the concept of static content and dynamic content, right? Things like that. We touched upon some tools like BeautifulSoup, and then I touched upon the DOM. So all these things, concepts will help you to think about how to build this application. I'll stop here. Oh, okay, last slide. And then, take a look. This is interesting. I just started reading about that. Now, crawl for AI. That's open source LLM friendly web crawlers. And another one is from Alibaba, NLP, called Web Agent. So, I don't know how, and it is open source, but these are all the, give you the idea behind building the deep research type of agent, which goes to the websites, web crawl, and then scrap it and give you the content that you need. So you may get a lot of wonderful ideas from these websites you build the crawlers and then scrappers for your agentic application. All right, and with that, I'm going to end. As we say always, you can please visit the SupportVectors.io. You will see a lot of great courses, and then a lot of this that I touched upon is part of the multiple courses here, boot camps and then LLM agents and building and stuff like that. With that, I'm going to stop here, and you can stop, Samantha. Then we can have QA if somebody has a question.